So Martha, are we free to start now?
What 1 minute to go until officially.
My time must be off. Sorry.
Yeah, Dennis, you'll be up first though to introduce our guest, and
Yep.
we'll go from there.
Yep.
We are recording, so
Awesome. Hey, Bill, do you have any kind of hemp objects in your collection?
Well, I do, but not at hand, unfortunately. But this is really exciting. Of course, you can make stuff out of virtually any plant fiber, and
Yep.
hemp is a pretty strong one because they used it for ropes for years.
Yep.
And no reason why that won't work great.
All right. Well, now it is 1:40, so
There we go.
It's my great pleasure to announce this lecture today. Jakob Frank, thanks for being with us. Jakob's an industrial designer, trained in Germany. He's also a luthierer, which means, for anyone who doesn't know, a guitar maker. He completed an internship in carpentry and product design before receiving his Bachelor of Art degree. Sorry, I don't know how to pronounce the university's name, Jakob, so I'm going to ask you to just give the name.
Yeah, it's called Hochschule. It's like German word for university of Gestaltung, of design, basically.
Awesome.
In Pforzheim, that's like the town where I'm at.
Excellent. And I invited him because I discovered my children are becoming more and more interested in musical instruments, the playing of them. And the only thing I can contribute, because I'm not musical at all, is the possibility of making instruments. So I've been looking at lots of guitars. We'll never make one like this. This is maybe way too technical for my luthiery desires. But in looking at guitars, I've become fascinated with many of them. And Jakob's process, I think, is quite interesting, not only as a way to make a guitar, which I think he's been innovating, but also as a way to think about hollow formed objects for industrial design. The space between a biomaterial from a fiber or a tree and what we think of as resins or plastics is a continuum. And the work he's making, I think, is a really interesting contribution to that continuum. And so we offer this lecture out of interest for instruments, for products, and for materials as part of the biodesign series. And from that, I'll say thank you. And please, Jakob, share your screen, and we look forward to hearing what you have to say.
All right. So I prepared a presentation. On my guitars, and yeah, on the left side you can see one of my guitars, and on the right side you can see the material I use for these guitars, and it's called Hempstone, and I will get into that a little later. And yeah, I didn't at all steal the slogan from Apple, but yeah, that's what I do. And before that, I also studied industrial design. And here you can see some of my work. And I wanted to put it in there to kind of show you what I've done before, and a little bit of the design language that I also use for the guitars. On the right side, this is like a toothbrush. The head is cut off so you can't see it, but I wanted to show it because of as well the design language. So on the side, or you can kind of see it's like this organic, almost biomorphic design, but with actual like highlights and some sharp edges. And I like when kind of organic design and like defined edges and defined shapes kind of meet and create like a synergy, let's say. Yeah, so I did a lot of lighting design. Actually won an award for this one in the middle here, and also did some sound design. So this is a sound system. It's based on this bass concept. I won't go into it too much, but yeah, always or already interested in like acoustic design. And yeah, so to go a little bit back, these are the guitars I built yeah, while I was like a teenager. and you can already see they are quite special, quite different. And yeah, it's actually one of the reasons why I started studying industrial design, because yeah, I like to kind of design my own guitars. I never bought a guitar. The white one here, I built myself. It was the first guitar I've ever possessed, and yeah, it went on from that or from there. And this is the first design for my Canna guitars. It was like 10 years ago, and back there I didn't know anything about acoustic guitars. I built electric guitars, but didn't know anything about acoustic guitars. And hold on. Back to this. So you can see it won't really work like this way. It's pretty bad design from like constructional point of view, and yeah, it's just rendering. So I didn't build it. I didn't have much time this semester, but I contacted Norbert, who is like making the Hempstone already, and started working with him. And 2 years later, I made my bachelor thesis with this guitar. And this one has a Hempstone body already. So this is in the back here, the beige material. That's the Hempstone. And yeah, this was like the first idea, first try of the guitar. And I built it together with another luthier called Konrad Sauer. He's from Stuttgart. And yeah, he helped me building this. My first acoustic guitar, and was like really fascinating how acoustic guitars work, because they're much more complicated, let's say, than electric guitars, because you have to actually know how to build them to make them sound good. It's not just the pickups. And yeah, so I continued like with my bachelor thesis. So this one on the left was a little bit earlier, half a semester before that, and then I did like my bachelor thesis. And you can already see the design changing a lot. And yeah, when I did like this pre-bachelor guitar, my professor told me that yeah, I need to do more design, not just like construction. So that's what I did here. And yeah, I already have like this headstock design pretty much developed, but yeah, pretty rough stage. And yeah, after my bachelor thesis, I just keep going. I kept going and kind of built these guitars, changed them, developed them further. Yeah, I changed like the sound port to the side and stuff like that. I won't get into too much, but yeah, it kept kind of evolving. And on the right, it's now basically what the design is today, and it's more like guitar design. So it looks like more like a guitar, not like a lute or some other instrument. And yeah, so these are a couple of guitars and instruments that I built. You have a bass guitar. One I built with a wooden body to try it out. This one has a fan fret classical guitar. Here are the ukuleles I'm building quite recently. This one in the middle, I will go into later. It's called the Ergo guitar. It's more focused on ergonomics, and that's why it's quite odd looking, but was a nice case study of kind of redesigning a guitar like from the bottom up, and kind of taking the principle of the ergonomics first and then kind of building onto it like the design. And also did a couple of electric guitars. This Telecaster style guitar is actually with Hempstone on the body. So the beige material here is Hempstone as well. It's got a wooden core, and the Hempstone is like on top, like a 3mm shell of Hempstone. And yeah, talking of Hempstone, I'm not a chemist, but I try to explain it. So on a hemp stem, you have like these fibers on the outside. And if you take the fibers and make paper out of it and kind of refine it, you have to roast it, you have to ferment it, a couple of processes to separate the fibers. and then you want to, or for hemstone, you want to mill them. And the secret of hemstone is to mill the fibers to a very, very high degree. So the finer the fibers get, the larger the surface area gets. And the more these fibers kind of attract each other and compress. So in the middle, you can see here the principle. So let's say these are like two hemp fibers, and you mix them with water. So we have the wet pulp, and when it dries, the hydrogen bonds are created here. So I think it's called hydrogen bonds, and it's like a big part of how these fibers kind of stick together. So there's no glue, no binder, no additive. It's literally just hemp fibers, and you make them wet and they kind of dry and get hard. It's basically like paper, but to much higher extent. And yeah, here on the right side, there is Norbert Schmidt, and yeah, he is like the guy who's making the hempstone. He's a chemist. He knows the material. He's been working with it for like 20 years. And yeah, if you have any more in-depth questions, ask him. He's the guy, and he makes the hempstone. And so he mills it. You need like industrial grade machines and to spray it on and stuff like that. So yeah, this is like a little bit of a example what's difficult about hempstone. So as I said, you spray it on, you see here, you spray it on a mold, and then it dries. And the pulp is very wet, so it's 90% water, and the water has to go out and dries and shrinks a lot. And when it shrinks, it kind of deforms a little bit. So here you see like a section of a body, and the mold is like the blue line inside. And after it dried, it kind of folded out. So it kind of comes out a little bit. So concave shapes are quite difficult. And also after we deformed it, you can see it kind of bent a little bit and kind of shrunk on the edges and kind of folded in. So this is like a body, it's a bowl, so it's hollow in the inside. And it's also one problem you have to face. And yeah, on the right side, you can see some examples how it would shrink. So the cylinder here in the middle, it says like textile, so it's wrapped in textile. If you spray on the hempstone, it will kind of create this hourglass shape when it shrinks. And for more complex shapes, it's like this. And I think I will show the videos of hempstone, how it's processed, how it looks like after the presentation. But yeah, this is basically how hempstone works. And yeah, I'm using it for my designs. And I want to go a little bit on how I go about designing guitars. And of course, there's a lot of sketching, and I like to do like these one-to-one sketches, so I can really see the proportions. And then I'm going to take it to Photoshop. And I basically use like 3 or 4 tools. I use sketching, Photoshop, and then CAD program like Rhino, and then mold making, like making or like model making with foam materials and so on. And I usually go back and forth between those. And every method has like its advantage and disadvantage. And I try to use every one like quite similar degree. And here's the latest ukulele. You can see there's like the body for this. And on the left, I made first a foam model for the body, and to see like how the ergonomics are. And then I tried to replicate it on like a 3D model, and made a cut model, and you can see it's much more refined. So yeah, it's an advantage of like AutoCAD or like Rhino, that you can get like these perfect surfaces. And it's also inspiring to kind of design it differently when you're using a 3D program. And it inspired me a little bit to kind of change the shape and kind of yeah, make it much more refined. And then sorry, I misclicked. Then I need to make like the mold. Mold making is like really difficult with hemstone because it can't get wet and needs to be solid and quite cheap and so on. But this one is like CNC routed, and then from there you spray it on this mold, and on the right is like the finished body. And for the design of the body, it's basically shown here. So on the right, you see these are the Ovation guitars. Everybody knows them, or any guitar builder. And they make these hollow, these round body guitars since the 70s, I think. And yeah, they have this round body design. And I heard from a lot of musicians and like other builders that yeah, it's very not ergonomic because it's sliding away, especially when you stand. And yeah, this because of this, I designed my body so it has like this double bowl. So these are like two like bowls, and in the middle there's like this groove, like this concave shape. And what it does is that you can hold the guitar much closer to you, and it doesn't kind of move around, and sits pretty tight. And also on the ukulele here, it sits more like on your belly, and kind of fixes it in there, and you don't really have to hold it so much. Yeah. Then I need to make like the molds, and I've done a couple of different methods of making molds, and it's always very challenging. But yeah, it's basically also very good to refine shape. And yeah, this picture says it all about like trial and error. So these are like, I don't know, 30 bridge designs. Each one took like at least an hour or two to make. And yeah, it's like one thing to draw something or to make a cut model, but you need to kind of build them in wood, like the material I'm going to use later, and also to kind of try them out and see how it works, and that I actually can build them by hand. Yeah, so this like is my main tool for designing, is like making them by hand, and each time a little bit different. And I also do like my bridges. I don't don't use a CNC to make them. And every time I kind of learn a little bit more how to maybe change a little bit and make it a little bit better. So it's kind of an evolutionary process. And yeah, I told you about this ergonomic guitar. So actually it was like an idea, not from me, it was from a US citizen from Washington State, Ryan Vader. And he approached me, he sent me this model on the right here. And he said he wanted to have like this ergonomic guitar. And yeah, on the left, you can see how it's been played. And yeah, it's a whole different way to hold a guitar. And yeah, you have to kind of change the body shape to kind of make it work. And it has like this round side on the bottom. And the idea is that it kind of sits between your lap, and you don't have to kind of hold it, and you can sit very straight, because playing guitars is always very strange on your back, like because you have to kind of hunch over and turn yourself, and it's a big problem for like classical guitar players that play a lot. Yeah, so this was the basic idea. And then I made a test run prototype. And for this, I used this just hemp fiber, hemp fabric and epoxy laminated. If you're interested, I made a YouTube video how I made this, and to kind of test drive it, the concept. And then after that, I made like the Ergo guitar, and here you can see I don't have to hold it; it kind of sits there. And it also had it to be like balanced, so I couldn't use my headstock, and I needed to kind of shrink it down. And so I came up with like this design because it's like reminiscent of my logo, and it needed to have like these concave shapes here, so you can hang it like the ukulele. That's like the thinking about behind the headstock design, and it worked out quite well. I think it doesn't sound so well. It's a little smaller, like the top activation is different. I don't want to go into it, but it works, but it's something different. It's not really possible to make like something that accommodates everything, like that you have perfect ergonomics, perfect look, perfect sound, everything. Another way to go about it is to have like this modular system, or like this additive. Like I have this lift here, I can stick in to the guitar. There are like two ferrules, I can stick it in, and then I can basically also have it like the same position, and or like a different position. It's more like Western style. This is more like classical guitar style. It's more like 45-degree angle. But there are like two different schools of thinking behind that. All right. This was like actually the first guitar, and I already had the idea back then. And on this one, you can kind of pull it out, turn it around, and then you have like two different modes of playing. Okay. So I want to talk a little bit about design, and I heard it's like a design lecture. So everybody knows like the mantra form follows function, but I want to kind of course form needs to follow function, especially on a guitar, which needs to sound good, and it needs to be playable, and it needs to be like ergonomic. And all of these things, they come first. But I also want to have like very attractive design, and more like this form follows motion, so a little bit more of a emotional design, not so technical. And on this bridge, you have like this is like pure technical. You have like this piece of wood, and you have a block you tie on the strings, and then you have like this bone saddle, and the strings go over there. And on my design, it's basically the same, but it's more like uniform, like more like integrated. I think it fits more like to the organic kind of theme of my guitars. And a little bit about the headstock design. So I heard from most people they like my headstock design, and I got the idea from this guitar on the left. It's from Cassini Guitars, and I adopted this like open headstock design. So it's not slotted, it's not a pack head where it's like solid. And I like it first because the tuners are like in this direction, and they are not sticking up, and it's easier to tune them. And I also like it because it looks very light. So this open look makes it look very light. And I'm using a couple of tricks here. So first I'm using like the separation, like the head plate is dark, and then like the wood is lighter, and this makes it already look a little bit lighter. these two comparison headstock, they use basically the same principle. And here you can see on the this ellipse on the Cassini guitar, it makes it look like the headstock is much thinner. And basically, because you look at the black, and basically the same thing goes for my headstock. But yeah, I try to kind of have more like uniform design, not so additive. You can see like this many lines here and a lot of things going on. And I like to have like, it's like one line that goes around, and then you have like one surface in the inside that's kind of wrapped around this line. And on the back you have a line, and kind of these two lines kind of hold these surfaces, and they kind of morph into it, so to say. And also a little trick that I use that also for example guitars, not guitars, cars cars use, and that's like these this line here. Every car has like this line. It's right below the window, and you can really see it on the Cybertruck. It's like on the, it's like this edge, and on the top you have like the light shines on the top, and then you have the dark on the bottom, and it makes like this stripe look. And what it does, it kind of pulls the design further, so it looks like longer. And for a car, it looks like faster. It looks more ergonomic, more aerodynamic. And yeah, the same principle goes for my designs. So on the headstock, you have always like changing of light and dark, and always like in the up direction here on the headstock, which kind of makes it look a little longer, and on the bridge, it kind of makes it look wider. And so this is like one basic trick I use. And here you can see on the back. So in the middle, this was like the first design iteration, and it's very reminiscent of the right one. And it's got like this thing here. It's called a veloute, and some like it, some don't. And yeah, I decided to change it so kind of these lines they flow into the neck and then disappear. It's a little bit like on the toothbrush at the beginning, so it kind of flows like that. And yeah, this makes it more like integral looking, more like flowing, kind of the headstock and the neck kind of transition into each other, and makes it look even like longer as well. Like you can't really tell where the headstock ends, so kind of moves into there. Here you can see when I have like these necks like raw, just like the cutout, you can see it looks very clumsy, very big, very heavy. And then I remove the material, and I remove maybe 25% of the material, but it looks much lighter. And that's because you make it round on the bottom side, and it makes it kind of disappear a lot of material, and makes it look much lighter than it actually is. And this is like my last slide. You can go with the question after that. So this is more like a little bit on like marketing, because it's, of course, if you want to do something like that, you need to do some marketing and get like some attention. And on the left you have the end presentation. This is like my professor Thomas Gerlach. And I noticed that everybody was very interested, like more than usual, and because it's guitars and then like this unique material and everything. And I actually got like into German television with my bachelor thesis here on the right, and like little segment, like a minute or so. But it was quite special to kind of get something like that. And of course, a lot of hemp magazines. They contact me. So I've been in 3 hemp magazines. This is Maximum Yield or something, and they have like a 4 or 5 page article here. yeah, and then I did like this TEDx talk, and they also approached me because I always try to kind of find new materials, and one of this new material, one of the organizers kind of found me through that. So yeah, and of course YouTube once blessed me with like the algorithm and boosted one of my videos, and it's got a lot of attention this way. So I was a little bit lucky on that that part, but you can check out my YouTube. I have a lot of videos explaining yeah, more on the technical stuff which I didn't touch, but which is like very like form follows function. So it's more important than the design because what makes the guitar sound good and feel good, and kind of also I think it's very interesting because I like this guitar design on building, because it's not just the design, it's building the guitars, and then it's like the construction of the guitars, and then a bit of marketing side. So it's very versatile, and yeah, that's why I like it. And I think we could end it here, and maybe I can show you guys some videos on the Hempstone, and let's try that.
So I'd like to, before I ask any questions,
Yeah.
just ask the group if they have any questions. And Ben, I would think you would have great things to talk about too with your own experiences, interests.
Yeah, I got plenty, but let's let some students talk.
Please leave, Jakob, please leave the video. That video up is great to watch while we talk.
Okay. Yeah. Yeah, I didn't notice it's already running. So here you can see it's running now.
No, it's static. It's up, but it's not running.
Yeah. Now it should be running, right?
Yep, it's running. Yep.
Yeah. So this is like Hempstone, Norbert on left, and we've made like this mold out of concrete, and yeah, here's how it's being sprayed on. Yeah, I tried it myself, but yeah, it's really complicated to really, especially to get like the thickness of the body, because you spray it on and it shrinks like 10 times. So if you want to go like 3 millimeters evenly everywhere, you have to put on like 3 centimeters at least of material, and then it gets like blown up, and it looks very yeah, here you can see it's shrinking. Yeah, it shrinks a lot. Can also show you the. Do you see the other video?
Yeah, sure. I think we have time.
I think I just share my screen. It's easier. I don't know how much time we still have. Yeah, couple minutes.
I think we can spend 5 or 10 more minutes, no problem. At least. So while this is playing, students, do you have some questions about the process or his design process or the trajectory? I mean, Jakob, how many years since you finished your last degree again? I forget. How many years you've been out of school?
I think it was 2016, my bachelor. So yeah, it's about 6 years.
It's, you know, this is a really amazing trajectory for someone after they finish a degree in design.
Yeah, it's also it takes that long to kind of get like traction. So I didn't sell any guitars for the first 3 years or 4 years. I think I sold one, and then it had like technical difficulty, and I had to give it back. And yeah, it's a lot. I had a little bit of money from my grandparents to spend on it. I was lucky that way, but yeah, you have to kind of endure a little bit until it gets like until it gets good enough, so you can actually sell it. But yeah, was quite journey, and it's very interesting to kind of explore the guitars and try out these different things like bass, ukulele. Somebody approached me from Britain. He wants to make like a lute, a kind of how's it called? These Arabic lutes. Oud. Oud. And yeah, it's very interesting topic.
So are there any, from the students, are there any questions?
Yeah, I have a question. I apologize in advance if this was already answered because I had a lot of audio problems, so it was hard to hear. But I noticed that you had, you were making like a Rhino model in conjunction with, all these sorts of physical prototypings. I was wondering, like, for a model as freeform as this, what's the, you mentioned like sort of like the precision, but like, how did you conceptualize this idea of like this very I guess, curvilinear form into a program like Rhino and make it smooth? Like, what insights do you learn throughout switching those processes?
Yeah, it's first it's like based on my guitar design. So like this, maybe I can show the ukulele for this. Yeah, so it's based on my guitar design, and it has like this asymmetric shape. So it's like more thicker on the bass side and thinner on the treble side. All of my guitars have that. And yeah, basically did a couple of sketches, and then yeah, it's a lot of back and forth, like a lot of mold making, sketching, and then like in the cut model, I've already been quite there. So let me put up the. Sorry for quitting the here. So yeah, you can see like on the left was like the basic idea. So I want to have like this asymmetric shape. And I wanted to have this cutout for like your body to fit in, because you hold the ukulele like a little bit tilted up, and you press it against your chest or against your belly. And I wanted to have this surface to be like more horizontal, so it kind of lays on there, so it doesn't slide away, because on the ukulele you have to hold it while you play it. So it doesn't sit on your lap. Usually you kind of hold it and you have to play the chords while holding it. And that's very difficult, at least for me. And that's why I wanted to have it like this shape on the back. So yeah, it's sitting here on the body. And yeah, then I made like these 4 models very quick, and then I kind of took it into a cut model, and yeah, basically try to clean it up and make it a little bit more defined. So like this one is basically just a sphere, and like the shape here, like the outer shape, it's basically one. I think I blew up a sphere. Like these are like 2 spheres that are intersecting, and then I have like the contour which I pull up. Yeah, so it kind
Jakob,
it cleans it out a little bit. Yeah.
One more detailed question about the process. So you make the physical. You sketched in both 2 and 3D, it sounds like. Then you made sketches that were very much the profile of the front, right? Then it seems like you then made a CAD model. Then you made a foam prototype, and then a CAD model. And in the CAD model, did you take just dimensions off of the physical prototype, or did you do anything else to analyze it? Did you bring photographs of it into Rhino, or did you do any?
Yeah, there's several ways you can go about it. I actually just freeformed it
Yeah.
because I pretty much had an idea what I want to go for. But if I wanted to kind of do the foam model and then import it into like this 3D model, you can use like these. There are like these 3D scanning tools for your phone. They work kind of well. It's a little bit hard to kind of make them work. What you could also do, you could take like this foam model and kind of cut it up, like slice it up, and then you have like the intersections which you could like transfer to piece of paper and then scan in, and then kind of use this as a reference.
But with the way you actually did it, did you take, as you're modeling, were you taking some measurements from your physical prototype, or you just know? I mean, you had to figure it out through a physical prototype, but the geometry you know well enough that you didn't have to measure again. You would just started fresh, but with you used the foam model like a sketch of sorts, right? It was a sketch model.
Yeah. Like you can see that this foam model it's very different than like the actual one.
Yeah.
So I kind of used it as like a baseline, like an idea, and then I went into Rhino and kind of changed it a lot there. It doesn't look like a lot, but yeah.
You also mentioned to me the last time that we spoke that you're thinking about getting a CNC machine to make some of your molds with. Do you expect, other than the labor of the final mold, do you expect that will change your process or not?
Yeah, I think a lot.
Yeah.
I'm quite limited because I don't have like the capabilities to like making molds like this. It just yeah, it's more precise, it's faster, you can do like different ideas much faster. So I made like an archtop guitar lately, and I made it like the top I had to kind of freeform like this archtop and make a mold for that, and it took like a day or so or longer. And like in CNC it would be faster to kind of do a prototype very fast and then work like by hand like the rest of it. And also for like mold making, I need to make like a lot of molds, a lot of templates, a lot of tools, pictures to kind of build a guitar. And for that it would be yeah, really nice. And also I want to get into it and kind of go on it. And I think it will also improve my design. So when I can basically make my real bodies, I made them like by hand and copied the molds. But if I could yeah, do it like this, the ukulele, it would as well clean it up much more. So yeah, it's yeah, would describe it as cleaning it up because it's more defined in that way.
Sure.
Yeah.
So, are there more questions?
Oh, I've got one. So you spray the hempstone material on a mold which is made from concrete, right? It's a positive mold, and then but then the material itself is going to shrink. Wouldn't that tend to crack it, or do you cut it in the middle to take it off the mold?
Yeah, I have to kind of cut it in the like in a crater, let's say.
Exactly. Okay.
I have to cut it.
You have to do that fairly quickly, right? Before it shrinks much.
No, it needs to shrink, and then after that we can cut it. Because if you would cut it before, it would kind of it will kind of
warp.
Move. It will warp like to the center. To the center of mass, it will move there, kind of go up there and shrink up there. So it needs like this. It needs like this counter force like on the bottom. Also, like you can see, he's spraying enough or the same amount of material on the bottom side because you need to have like this counteracting force that's kind of pulling it around it, so it doesn't escape like basically to the top.
Yeah.
That was exactly the question I was going to ask.
Yeah. What's the final thickness? What's the final thickness?
Yeah, it depends. We did a couple of bodies who had like 1.5 millimeters, but it's too thin. And usually we go about like 3 to 4 millimeters. That's like pretty good. the bodies weigh like 750 to 800 grams this way, and that's pretty good weight. But yeah, I would like to have a little bit lighter because guitarists like light guitars, and but there's like a trade-off a little bit. But you can go much thicker as well. So you can also do like block material. So this is like a block of hempstone, like
yeah.
cut out.
And you can
And
machine that?
You could machine that, yeah.
Yeah, I got you.
And this is like a hempstone, so it's just some excess material. And yeah, it's very hard. Like it's really stone, and you can't scratch it with your finger. It's like really yeah, super hard. And it gets harder when it's like in a form where it can freely compress, so it can freely shrink and kind of doesn't there isn't anything in the way. So
yeah. And do you put a shellac or a varnish on the outside?
yeah, usually I use shellac. So I use usually oil, and then after that I put on some shellac. Yeah, for example, I made like this coat hanger, and yeah, it's hempstone. I put just hempstone over there, like by hand, and it shrunk and created like this ridge here in the middle. And then I just put on some oil, and yeah, to finish it. And
well, it's a beautiful material. Yeah, it sounds really exciting.
Yeah, another thing we were just talking about, I'm sitting here with a visiting scholar of mine, Ramtin, and he's very interested in parametric design and robots. And I was just thinking to myself, like, the skill to spray that is something that, of course, it's great to have this relationship you have, but it's not very portable to around the world. But if we could use a robot to do the spraying, one could get it you could tune the thickness, but not have to have the skill, right?
yeah, actually Norbert said he was dreaming about having like these car arms, like these
Yeah.
kind of robots to spray it on. So you could train the robot to kind of make it perfectly spray it.
Yeah.
And
maybe that's a future collaboration for all of us.
yeah, if you can do that. Yeah, the other thing is about hempstone, it's really hard to kind of make on your own. So you need like you need paper mill. So Norbert has like a smaller size but industrial grade paper mill, and you need to know how to operate it, because you need to kind of mill it a lot, so it gets like to the edge of the machine. So it gets very, very dangerous for the machine because you need to mill it so fine. So you need a lot of tools and like big machines and specialized tools for. And it's also it's hard to ship because it's like a wet pulp, and it would be really, really hard to get it over the border.
Yeah, I hear you. But you can just put it on by hand. That's obviously what we're watching now, right?
Yeah. So there I tried to kind of put it on by hand, and you see I have to kind of slap on it. And that's to make like the fibers connect. So you need like some impact force that the fibers actually connect, so that they don't have like these layers and kind of separated.
When you do it this way, is the shrinkage the same, or is it denser so it shrinks less?
It should be about the same. The spraying on is like just it's more homogeneous, and you get like less like pockets inside. Here, when I put on something, could create like some air pockets inside and some failures, and it could also crack. So I think this one I made like myself also by hand.
Yeah.
And yeah, you can see what could go wrong.
Feeling forward.
Yeah.
And yeah, it's really like in the end stage, it creates a lot of tension, and then once it starts, it kind of cracks through. And yeah, this was because I had like this. I think in the beginning there was some sharp edges. I like this wooden thing isn't. I put it on later, but there were some sharp edges, and then that's where it's like started, and then worked through.
They kept going. Yeah,
Yeah.
it's
Yeah,
beautiful.
I mean, you want, I just wanted to
Go ahead, bro.
No, I mean, I was going to ask the same question. I actually have two quick questions. One relates to what Bill said, and one relates to what Jonas had said. For the comment about robots, it seems like, you know, right now in automotive production, I mean, they use robots, of course, to like spray paint chassis and entire all body parts. And they're tuned very carefully to make sure that they spray a very consistent amount of paint. So I think what Jonas was proposing, I'm sure that could be done. There are some precedents, I think, here that could be applied should automation be the goal. But the question I had was more kind of about what happens after you apply the hempcrete sort of all around the circumference of this kind of more rounded mold. So I understand the whole thing about shrinkage and cracking, and that would have been my question as well. But I'm also wondering, so if you're basically cutting the part sort of along the sort of quadrant or the sort of equator, what happens? Can you take the material on the bottom side and then reuse it? Or what happens to the leftover material?
Yeah, the leftover material is basically excess. So you can't really put it in water and dissolve it again, kind of spray it on. That doesn't work. So you would have to kind of grind it again. Robert says,
but it can be reused. It can be reused again for another spray.
I'm not sure. Robert isn't doing it, but I'm not sure if it would work.
Yeah.
He says you need to put in the energy then. That's basically.
But basically, your fine grinding is in order to make the material stick together, right?
Yeah.
Yeah, and in working with fiberglass and glass fiber reinforced things, sometimes we used to use a mixture of very finely ground material to get it to stick, and then longer fiber material in order to give it more tensile strength.
Yeah,
have you tried that?
Yeah, there's also like some long fibers in there.
Okay.
So it's also mixed exactly for the same reason. So the smaller fibers is to make it like shrink more, and the bigger fibers is to prevent it from like cracking or tearing up.
You got that one already. That's wonderful.
And you can go like much further than that. So Norbert did some experiments to make the fibers like even smaller, and then it gets really like a horn material, like bone. It almost gets like translucent. It could be. It's not like the end. Like, it could still push it further. Yeah.
Well, basically, you're effectively making your own wood here out of plant fiber.
Kind of.
Yeah.
There's no lignin in there, but it's basically fibers and some pigments. So here in the beginning, you can see you have to put in some pigments.
Yeah.
And you need to use like mineral pigments so they don't dissolve in water. So they would be transported out if they would be dissolved in water. And that's like hemp fibers, pigments, and that's basically it. This is like when I was studying, we made like these molds. Norbert is like chemist, and he did like this concrete with like, I don't know, 15 different ingredients.
So he is a chemist, by the way. Is he like a self-trained chemist, or he's actually a chemist?
He's actually a chemist, yeah.
So chemist, and he makes didgeridoos and drums. You said, right? That's his.
Yeah.
Yeah, it's such an interesting combination when you have that science mind and then the creative mind together, right?
Yeah, he used to work like in medicine and crit, and he bought like this huge factory. It's like former a textile factory. It has like different halls and endless space, and he builds his digital booster and yeah.
Does anyone else have a question?
Got a question. I got a bunch of questions, but I got,
Is
there a- is there a stu-
Yeah,
is there a
Henry, go
student
first.
that has a question? How about
And
that?
Marcus
I can
can
ask.
do.
I have
Oh,
a
there are some
Yeah.
students.
Sorry, go ahead.
Henry, go first.
okay, I'm going. So are there advantages to using hempstone for the sound of the instrument over wood?
Yeah, it's good questions because yeah, it's basically the first thing everybody asks me, how does it sound? And the answer is that on my guitars, because they have like this this round body, it's already pretty stiff. So a normal back is a normal guitar. You have like the top is straight and the back is straight, and so the back is as active as the top usually. It depends on how you brace it, but on like this design, it's already so stiff and so sturdy that it doesn't make that much of a difference what the material is. But still, I think hempstone is pretty. It's more like neutral, so it's more like the top is doing all of the work and the back is basically reflecting. It's a passive back basically.
Yeah, so you think it's more the shape that makes a difference on sound?
Yeah, in my case, the shape makes it so it's so stiff that it doesn't matter as much what the material is, I think. But I also think that the round bowl is like reflecting the sound a little bit better. Like when you're in the cave and you have like these cellar, like round cave shaped rooms, it's very acoustically live, and it's because there's like no edges and no corners, and kind of the waves, sound waves can bounce off much more easier. So I think, yeah, it was like for my guitars, for example, it was like the idea that I have like this bowl here, which is like a parabolic mirror that's kind of reflecting back to the top. Yeah, so I have like this kind of mirror that's kind of reflecting back and it's hitting the top, and then it's bouncing back and forth. Yeah, but I think like on acoustic guitars, there's like always a big question about tone woods, and a lot of builders make like a big deal out of it, and I think it's a little bit overrated, especially for the back of the guitar. So you have like Antonio Torres, who invented the classical guitar, or basically acoustic guitar, and he built a guitar out of papier-mâché. So basically the same. So papier-mâché, even like less vibrant material, and it worked for him. So it's yeah, he basically proved that it doesn't matter too much. So the most important thing is like the top, how the top is constructed and how it sounds.
Thank you.
Yeah, so for my question, I know with wooden guitars, they normally have neck joints to connect the neck and the body, but with a shape like that and a material like that, how do you connect the neck to the body?
Yeah, so you can see that this neck is like sitting on top of the body. So there's like no heel, and there's not really like a block inside. So I use like this frame construction, where it's kind of sitting on this frame. So this frame is like 8 millimeters thick, and the top is inside of the frame, and the neck sits on top. And then I have like a brace below that. That's kind of taking the pressure. So the strings are pulling like with 120 kilograms here, and that's making it push in here a lot. And I have basically this brace on the inside that's taking the force here, and yeah, the neck is basically just like a dovetail like into this frame. and it was really hard to kind of figure it out with like the wound back to attach a neck and attach a heel and kind of make that work. And so I came up with like this design where it's basically sitting on top. So you don't have to worry too much about like the round body and how to kind of fit something on there, because that's always really complicated. And yeah, I thought a lot about it and couldn't make anything work. And then actually it was an accident and that brought me to like the idea to make it like this.
One last question. So since you're doing it like that, how do you know where to place it? Is it just dependent on the scale length on what fret you're placing it on, or how do you know like the exact spacing for that, where you're placing it?
Yeah, that's really yeah, you're right. You have to place it like very exact. So if you just tilt it like 1 degree, it sets off like the bridge too much. And you later have to intonate the guitar, so like the tenths of a millimeter matters. You have to put it like in a really right spot. So yeah, I also like going back to like the CNC and the mold making and stuff. It would also help a lot to make like very precise locations. So because I'm doing it all by hand, I have to double and triple check everything, so it sits on the right place. And then I do it this way so that I put in like the neck pocket first, and then I put on the bridge. So the last thing I kind of adjust is the bridge, and then yeah, it usually works. So a couple of guitars it was a little bit off, and then I had to adjust like on the bone. It went a little bit like crooked, but yeah.
Hey, we should probably wrap in a few minutes. This has been amazing. But Ben, I bet you have one good question left for us, so we can close with your question.
No, I don't have questions. Many of them have already been answered. I was curious about how the material adheres. You said it could be machined, but screwing it in, is it brittle? Is it flexible? Do you have any problems with the glue adhering to the top, the soundboard, the neck, any of those joints? I could ask you probably a bunch of questions. I'm sure many of us could. That's really the one I had at the moment.
Yeah, so here's a piece of Hempstone as well. You can see the different layers. And yeah, at the end, it gets like really, maybe I make my picture. No. Yeah, really, at the end, you can see like, it's like layers of paper. So it's basically paper. It's like many layers of paper that's sprayed on. And it gets like this hard because yeah, it's now solid and it shrinks more. And because it's paper, you can kind of glue it using like wood glue, regular Tide Bond I use. Works very well, and it sucks oil, but you have to be very careful about water. So when you get water on it, like spilling some water, it's not that big of a problem, but if you put like water on it and then kind of rub it, you can rub off the fibers. So because the water goes in there and the hydroxyl bonds kind of dissolve, and then you can kind of rub it away. So you would have to put on some oil, or like here some finish, some oil, some shellac. Normal lacquers I used before, they also work. Yeah, basically like wood. It's maybe sometimes better than wood, because wood usually has some resin in it, like tropical woods. Could be harder to work with.
Thank you so much for the amazing lecture today. We're really grateful for your time, and we hope to meet again. And I really would love the opportunity to see how maybe we can collaborate in the future.
Yeah, would be great. Can also talk to Norbert. Maybe you can make something work.
My pleasure. Everybody, let's give him a hand.
Wonderful. Thank you very much.
Thank you, Jakob. Wonderful lecture.
Have a great day, everybody.
Thank you so much.
Thanks, guys.